All right, sixth grade. Continuing on in chapter 12, and today talking about inequalities. Okay, inequalities. And first, we're going to start off with a definition of inequalities. So, an inequality is a mathematical sentence stating that two expressions are not always equal. They're not always equal. So, what we've been working with so far are equations, which means one side of an equal sign is equal to the other side of the equal sign. So whatever's happening on one side is equal to what's happening on the other side. Inequalities are not that way, okay? And we have 5 different inequality symbols that we use. We have is less than, that one. We have is greater than, that one. We have is less than or equal to, which also means is at most. That might be a new phrase for you, okay? Is at most. So is less than or equal to is at most. That means it cannot get bigger than whatever that is. Then we have is greater than or equal to, which also can mean is at least. So it might be this or might be even bigger. Is greater than or equal to or is at least this amount. And there's our symbol for that one. And then our last one is not equal to, just an equal sign with a slash through it. Okay? So we are going to be doing some translating word phrases into inequalities, into these mathematical sentences. So example number 1 says, write an inequality. The sum of n and 9 is at least 12. The sum tells us we are adding, what are we adding? N and 9. N plus 9 is at least 12. That means n plus 9 might be equal to 12. It's at least 12. So it may be equal to 10, but it might be bigger than 12. Is at least means it's either equal to 12 or bigger than. So n plus 9 is greater than or equal to 12. Part B, a number less than 3 is less than 5. So please notice the distinction here, okay? We have less than and is less than, okay? So less than is what we were working with earlier in this chapter that means subtraction. Is less than gives us an inequality, all right? So that's the difference here. So a number less than 3. So remember what that means is 3 minus a number. So 3 minus x is less than, so it is less than, and what is it less than? It's less than 5. So 3 minus x is less than 5. Skill check number one, write an inequality. The product of 5 and h is not equal to 7. Product tells us multiplication. What are we multiplying? We're multiplying 5 and h. This is the proper way to write that. 5h is not equal to. Is not equal to. What is it not equal to? 7. Number 2, the sum of 5 and the quotient of 3 and x is at most 2. So sum tells us addition, quotient tells us division. So what are we adding? The sum of 5 and, so we're adding 5 to something. 5 plus the quotient of 3 and x. Quotient says division. 3 is the numerator over x. So the sum of 5 and 3 over x, so 5 plus 3 over x is at most 2. That means it might be equal to 2. At most means it cannot be bigger than 2. So that sum has to be less than or equal to 2 because it is at most 2. It might be 2, but it might be less than 2. So 5 plus 3 over x is less than or equal to 2. Now, inequalities have more than one solution. Think about this inequality that I have written here. X is greater than 2. Is 4 greater than 2? Yes, 4 would be a solution to that. Is 97 greater than 2? Yes, 97 would be greater than 2. Is 2.1 greater than 2? Yes. So 2.1 is a solution. Guys, I could sit here all night, okay, and talk to you about this. There is an infinite number of solutions. There's an infinite number of values that we could substitute in for x that are greater than 2, okay? Any of those answers that we could substitute in for 2 or in for x that are greater than 2 will make the inequality a true statement. So example number 2 says, for which inequality is 15 a solution? So what we want to do is look at A. It says 2 plus 5x is less than 7. What we're going to do is we're going to substitute 15 for x and see if it makes this inequality statement true. If it does, then 15 is a solution. Let's check and see. So 2 plus 5 times 15, because we're substituting 15 for x, okay? Let's figure out what that is. 2 plus 5 times 15. 5 times 15 is 75. So 2 plus 75 is 77. Now, is 77 less than 7? No, it is not. So 15 is not a solution for this inequality. It does not make this inequality true. Now, let's check with B. Substitute 15 in for x. 3 times 15 minus 13. That's 3 times 2. 3 times 2 is 6. Is 6 less than or equal to 6? Yes, it is. It is equal to 6. So 15, yes. 15 is a solution to this inequality. Skill check number 2, is the value a solution? Okay, 4 plus 8p is not 0. Let's plug in negative 0.5 for p and see if that makes it true. 4 plus 8 times negative 0.5. Okay, that's 4 plus 8 times negative 0.5. That's the same as 8 times negative 1/2. So that would be negative 8 over 2. Negative 8 divided by 2 is negative 4. 4 plus negative 4 is equal to 0. So is 0 not equal to 0? No, 0 is equal to 0. So guess what? Negative 0.5 is not a solution to this inequality. It does not make it a true statement. How about number 2? N minus 6 over 5 is greater than or equal to 8. Substitute in 51 for n. 51 minus 6 over 5. 51 minus 6 is 45. 45 over 5 is equal to 9. Is 9 greater than or equal to 8? Well, yes, it is. 9 is greater than 8. So 51, yes. 51 is a solution because it makes this inequality true. Now, one of the best ways to picture a solution for an inequality is to graph it on a number line, okay? Because we can show how the values that can make the inequalities true are infinite, okay? So let's take our x is greater than 2. What we do is we start at this value right here. So we're going to start at 2, and I'm going to put an open circle here. Now, when we graph inequalities on number lines, we have open circles and we have closed circles. An open circle means the number that we are drawing the circle on is not a part of the solution set for the inequality, okay? A closed circle says, yes, the number that we are putting the circle on is a part of the solution set for the inequality, okay? So open circle, not included as a solution. Closed, included as a solution. Okay, so open circle on 2 because this statement says x is greater than 2. So x is anything that is greater than 2, but it is not equal to 2. So it cannot be 2. Now, the values that are greater than 2 on a number line move to the right away from the number. Okay, a move away from 2. They get bigger. So we draw an arrow pointing the direction from that open circle at 2, like so. This shows us all of the possible values for x. X can be anything that is to the right of 2. It cannot be 2. Example number 3. Graph the solutions. X is greater than or equal to 4. So x is anything that is bigger than 4 or is 4. So we find 4 in our number line, and we do a closed circle at 4 because it can equal 4. Now, do we shade to the right? Do we draw an arrow to the right or to the left? Well, x is anything bigger than 4. Where are the values bigger than 4? They are to the right of 4. So I draw an arrow that goes to the right. Part B, x is less than -3. Find -3 on your number line. And this is going to be an open circle. Here's -3. This is an open circle because it cannot include -3. X is anything smaller than -3, but it cannot be -3. Now, smaller numbers to the left or to the right of -3. They are to the left. So my arrow is going to go to the left from my open circle at -3. C, x does not equal 2. So that means x can be anything that is bigger than 2 and anything that is less than 2, but it cannot be 2. So I put an open circle at 2, and my arrow goes both to the right and to the left. Doesn't include 2, but it can include anything else. There's my number lines. Now, skill check number 3. Graph these. P is not equal to 0. So P is anything but 0. Open circle at 0. Arrow to the right as well as an arrow to the left, because P can be anything that is smaller than or greater than 0, but not 0. B, x is greater than 5. X is greater than 5. Find 5 on your number line. It's an open circle because it cannot include 5. And x is anything that is bigger than 5, not less than, bigger than. So we are going to go to the right to indicate that x is anything larger than 5. And the last one, C, y is less than or equal to -3. So y, find -3. Y can be -3, so it's a closed circle. It can be -3, or it's less than -3. Numbers that are less than move to the left. So my arrow goes to the left of -3 from my closed circle at -3. And that is this lesson, my friends.